Hi guys, welcome to Friday's lesson. Today we're looking at 9D, planar graphs and Euler's formula. So just wanted to note, this word here is pronounced Euler. Cool. So we're just looking at a different kind of graph today, and that is a planar graph. Whether I'm saying that right, I don't know. So a planar graph, let's get the highlighter out. Planar graph can be drawn so no edges intersect or cross over. Okay, now some graphs, which is very good to note, some graphs don't appear to be planar but can be untangled to be drawn as a planar graph. So the graphs down here, we've got graph 1 and graph 2. They are the same graphs, so that's why we use the word isomorphic, okay? It shows us the same information. However, one is planar, graph 2 is planar because it doesn't have any of their edges crossing. However, if you look at all the information, it's the exact same information. All of the edges are joining the same vertices, so they are isomorphic. Some graphs can never be drawn as non-planar, no matter how hard you try. So you can keep trying. You can write A, B, C, D, E, all these vertices in any way you like and try to join them all up. But for this one, you'll never be able to do it with them not crossing over. So that's a planar graph. Another thing we're looking at today is faces of a graph. So what that means is that your vertices, or the edges that connect the vertices, the edges will form a region, which is what we call a face. Okay, now this is very important to note, which it's got here. The outside space counts as one face of the graph. Okay, so for this first graph, all of the edges form a region, which is this F1. Okay, that's one face, and you've also got to count the outside as another face. Out here. Okay, so number of faces is 2. So for this next one, you've got the outside face. And then for this one, your edges actually make 3 different faces. Your edges make the 3 different faces, plus the outside, which means there are 4 faces of this graph altogether. So that's really important for our next bit, which is Euler's formula. So Euler's formula. Euler discovered that for a connected planar graph, there is a link between the number of edges, the number of vertices, and the number of edges. Okay, so just to unfold that a little bit, so Euler's formula, it's going to include number of vertices, okay, so the little circles, little dots, and then you need to know the number of edges, which we know are the lines connecting. And it also includes the number of faces, which was what we've just learned today. So the number of faces are the area or the region or how many regions that the edges make. Now, he found that if you get the number of vertices and you subtract the number of edges, then you plus the number of faces, it will always equal 2. This is only true, and I'll put a little note here, only true if the graph is a planar graph. Planar graph. Okay, which means it's only true if you can do the graph with no overlapping edges. And it's got to be connected, so that means there can't be any disconnected vertices, which we looked at yesterday as well. So with that, there's a formula, which is here. Okay, so we're just using the letters to denote the parts of the formula. So V is vertices minus E for edges plus faces equals 2. Okay, they use this in VCE or VCAR exam, so it's very important to be able to identify that that is Euler's formula. And here's the note that I just wrote up there. If Euler's form works, the graph is planar. Okay, so if you get a question that says, prove that this graph is planar, you would be using Euler's formula to prove that. So here's some examples. So for graph 1, Okay, so for Euler's formula, you need to know the number of faces. So this one, it's got one here and one here, so it's 2. Okay, then you need the number of edges. So for this one, 1, 2, 3. Actually, I'm just going to do another little. We've got 1, 2, 3 edges, so that's good. And the vertices, we've got 1, 2, 3 vertices. Okay, now you put that into your formula. Okay, so vertices is the first number. Then we've got edges is, we subtract the edges, and then we plus the faces, and that should equal 2. Okay, so yeah, 3 minus 3 is 0, plus 2 equals 2, correct. So therefore it is planar. Okay, sorry, I just realized up here, this one, these are the same, okay, they're just written differently. But you still substitute in your values and you can still work it out, it's still fine. So this graph 2, again, same kind of thing. You need to find the number of faces. So you've got 1, 2, 3, 4. Good. Number of edges. 1, 2, 3, 4, 5, 6, 7, 8 edges. Number of vertices. So you've got A, B, C, D, E, F, which is 6. Okay, so you put it into your formula, 6 minus 8. Now, there's a little error here. I'll have to tell Miss Savage off for that. 6 minus 8 is negative 2. Then plus 4, which is 2. So therefore, it is planar. Okay, therefore, if the graph is planar, that means that none of the edges overlap each other. And that's 9D.